just going to wait another minute or so. Wait for some of the stragglers to show up. If you are watching, you know, everything seem okay. Like we seem to have comments. Like the live chat is present, but everything sound okay, look okay, etc. Okay, so 6 are here. That's about everybody. Yeah, let me know if something falters or seems out of sync. Either my camera, voice, whatever. Just let me know in the live chat. Also, if you have any questions, please feel free to use that, and we can actually communicate with each other this time around. What I think I did, or whatever I figured out. Oh my god, my dogs are idiots. What I figured out is like I have my settings like made for kids, and I guess if you do that, automatically turns off the live chat and comments. So whoops. So hopefully everything will be straight from more or less from now on. All right, so we're still going to mess around in R Studio, kind of expanding on what we've already done before. So for example, like we've already played around in the actual console. So this lower hand right thing is or lower left hand corner. We're just going to call that the console. I'm not worried about the other things, but this is where commands effectively go. Now, what's important, or what's nice about programming languages, is saving your code, and so R lets us inherently do this pretty easily. So I'm just going to do a handful of things. So I'm just going to remind ourselves of a few things of what we can do. I don't know if I've already done this before, but if I want to say make a specific vector. So what we've played around with vectors that look like this. We take a set of numbers between a start point and an end point, but we can also fill a vector with whatever we want to. So by doing so, I don't remember if I mentioned this or not, but if we want to make a custom vector, then we use a C in parentheses and then fill in these values that are going to be comma separated. So we can have, 10, 1, 2, 4, whatever. Just a set of numbers. I don't think it matters if they're integers or not. It should be saved. And so that just fills up a vector as a custom vector. Of course, we can save this as whatever we want, vec test, and save that, right? All right, just reminding ourselves of what the terminal can do, and we can save stuff. So you're going to see me save variables in this kind of fashion. So it's usually, we call this a camel hump. I'm just writing this down up here, camel hump. And camel hump is kind of like this notation where the first word in a phrase is not capitalized, but subsequent words are. So I tend to avoid, and we should all tend to avoid special characters in naming schemes whenever we name a variable. So for example, like periods are bad, commas are bad, question marks are bad, hashes are really bad. Percents, dollar signs, these are special characters that we really, they mean stuff. And so we should not use them whenever we make store vectors, because these characters have specific meaning. So one that we're seeing, one I'm kind of already playing around with, one of these special characters is a hash. I kind of feel like I'm getting ahead of myself because I'm really not describing what's happening in this upper left-hand corner. This is where I can write down code, but simultaneously run it in the terminal. So for example, I can still do vec test, and just so we can see how it changes, or I'll set a new one, vec test 2. Nice thing about R really doesn't care that much about white space. So if I have comma space 5 or no space in between commas, R shouldn't complain. It should return the same thing. And so I can go ahead and run this in the terminal. So I'm going to do this a shortcut. And the shortcut is to highlight the text. And then in Windows, it's Control Enter. I think on Apple, it's going to be Command Enter. And so whenever I do this, I can do my Control Enter, and it's going to send that line to the terminal and run it there. And so vec test 2 has been saved, right? But this isn't the only thing this upper left-hand pane can do. I'm slowly working up to this. So for again, this lets us effectively save our code, and this upper left-hand thing is effectively like a scripting tool. This is a scripting tool where we can write down our code and then ultimately save it, so we don't have to keep having to remember it or write it down onto pen and paper and remind ourselves about it. We want to make our lives as easy as possible. And honestly, I think whenever I was first introduced to R, I don't think that I was introduced to it in a practical way and using it in a practical manner. It was like, this is what R can do. Don't worry about saving your code or scripts or anything like that. It was like, type these commands into R and your stuff will work. And I don't think that's entirely practical. That's definitely not practical. But anyways, I'm going to fill this thing up with commands that we've already seen before. So for example, x, I'm going to set it equal to numbers. I'm just going to do like our slope of a line stuff that we've already done before. In setting these variables, and b is equal to whatever, random numbers. And then we have our linear equation, just a linear equation, y equals mx. There's probably a better way to do this, but nonetheless, mx plus b. And as I mentioned, I can just highlight all of this stuff, do my Control Enter, and it's going to be sent to the terminal to be run there. Okay. All right. And so, if you haven't noticed already, where I've put this hash character, everything after that is green, whereas everything else is going to have a black and blue color. And that's because of this property of a hash. And so in almost every language, computers can't or won't read text after a hash. And so hashes are handy to make comments in code that you can read, but the computer cannot. And so if I try to let's see what happens. If I try to highlight this and try to run it, let's just see what happens. I don't know what's going to happen. Nothing should happen. But I run that to the thing, and ultimately nothing happens. Ultimately nothing happens in my terminal, right? It's going to run the code, but it's basically reading invisible statements. So it can't be processed. It's not going to give me any errors. It's really like R can't read this, so it's not going to perform any commands. And so, for example, Again, we can write notes into our code to help us remind ourselves what we're doing. So for example, like I might write down slope of a line test. Right, and so I know everything under this hash, everything under this comment is related to just slope of the line. And so anything that we have behind a hash is just called a comment. Right, so you can comment your code, and especially if you tend to make your scripts public, or if your memory is kind of lapse, you kind of struggle remembering what you did. Comments are super helpful. And usually, so I've seen this done a handful of times. I will readily admit that I don't use comments nearly as well as I should. For a couple of reasons, but the primary one is I usually don't make stuff public. And if I do make a script public, then yeah, I'll comment the crap out of it. But if I have no intention of releasing it to the public, it's just for me, I tend to be able to just read my code and know what's happening. I also have another couple of tricks to remind myself of what I did. So I usually don't comment stuff out, but that's definitely not what you should be doing. That's not what anybody should be doing. It's just a bad habit. And so it's not uncommon to say like, to put your name and date a script. So Mike Van de Weg, date would be like whatever today's date, 1/27/2021, and what the purpose of the script is. So you may even have like author, and this might be more important for big labs or big communities that would share their code around each other, so you can kind of keep track of who wrote what and when. And also kind of a general description of what this script will be doing. So this is just test commands and saves, playing. Right, so we have all these different comments in here that I can read, but the computer won't. So whenever I try to run this stuff, nothing will happen. I don't know. Let's just populate this stuff with other commands. I promise I'm getting to a point here. Just messing around. Right, so we just have some silly little commands in here. I'm just populating this script with very simple commands. Okay. But as I said, so if we look up here on this upper left-hand thing, we see this untitled, untitled script, basically a script name. And so if I want to save this, I can just go to File. Well, first, before I do anything like that. So first off, I may want to designate where I want to save this. I don't want to just have this script saved to a default space. I want to put it in a specific folder so I can access and kind of quickly find it later. So I may go to my desktop. So what I'm going to do is just make a test, literally a directory called test on my desktop. You're not going to see me do that. But that's something I'm doing. I'm just going to make a new folder on my desktop and just call it test. I already have a folder named test. Son of a biscuit. Test 2. Okay, no problems with test 2. You'll kind of pick up this pattern as whenever I'm just playing around. I'll just name stuff test. because I know I'm not really serious about it. I'm just kind of playing around and I'm testing stuff with it. But anyway, so I don't use all of these menus very often, but they all have certain functions. I don't touch them that often. The one I touch the most is sessions, because in sessions I can designate where I want to receive or where I want to save data and where I want to retrieve data from. So whenever doing so, I'm going to go to sessions and set my working directory. And so a couple of different ways we can do this is save to wherever the script is already open at, or we can choose a directory. So we're going to choose a specific folder where I'm going to save stuff to. And so directory, you're going to hear me say directory a lot, and you'll hear directory, you'll read directory in computer lingo pretty often. It's synonymous with folder, not to be confused with file. So anyways, I'm going to choose my directory, and I'm specifically going to go to my desktop. And I choose my desktop because I can observe it easier. I can kind of watch what I'm doing easier. Okay, so I have test2, and so I'm just going to select that folder, right? And so nothing's here because I haven't saved anything here. But I'm just gonna open this, and now I have set my working directory. So it's just whenever I do this, it's just going to run this R code that specifically says make a new directory at this location. So in users, my desktop test2, right? And so now I can save my script to this specifically to test2, this test2 directory. So I'm going to save this as just an R script. So inherently it just opens up this test2 directory. So I'm just going to save this as, playing test.r. And these extensions, right? So you've probably seen extensions on some files, like .doc, doc, xls, etc. So an extension effectively defines what your file is. It at least tells a computer how to read that file. I should say it that way, because the extension really doesn't matter most of the time. Most of the time what I do, the extension doesn't matter, but calling it, providing a specific extension, would imply that my computer will just go ahead and treat it like that file. So I'm saving it as an .r file, and so my computer is going to read it as an R script. But I could easily save this as txt, and it's still going to behave the same. But that's stupid. That's bad etiquette to do such a thing as name an R script as a text file. So I'm setting this extension as .r, and again, this just kind of tells my computer that this is an R script. And also, whenever I look through my folders again, after I've forgotten it for a year, I can tell which of my files are R scripts and which are plain text files, which are Excel files, etc. So it's both for me and both for the computer to make sure that your extension of any file is named appropriately. So I'm just going to save it there. And so if I go over to my test directory, test2, that script is now present. And so this playing with our test script is present. And so basically it's been saved. So I can close down my window and basically reopen it and have the same commands ready to edit. I can also open this in a plain text editor. So like my go-to is Notepad++, but I know for the Mac users, you don't have a Notepad++. You have to find something else that's equivalent to it. But yeah, so it's just a plain text file. It just has that extension .r. Right? It has all my hashes, has all my commands, and so I can save this and rerun it in the future. So for example, I'm just going to close that, and close everything else down. And so I can just go ahead and inherently just reopen that file, and that's going to load inherently in the top right corner and just be present again for future editing. Right, so most important thing about that is recognize sessions, set your working directory, and saving a file. Okay, and so I can inherently, I can run this script. So I can run every command in this script on the terminal itself. And so this is something that I'll do back and forth, is I'll make my script, I'll edit my script, and then run it in the terminal. So if I were to do this, I would do source tabs. Tabs are really important. So your tab button helps autofill commands because we're all bad at spelling, and if something is misspelled, if a command or a function or something like that is misspelled, it won't work. But you can get around that spelling problem by using your tab key. And tab is effectively an autofill. So I can do soar. It's going to bring up these two different options, and yes, I want source, and I can just tab over and autocomplete it. And with source, now I can use quotes. So I can, with source, I can access my scripts in this specific directory. So basically, it's effectively a run command. It's so you have this button up here in this upper right-hand corner. That's a run command that will run this entire script as is. That's fine. But traditionally, this is just how I've done it, is that and whenever I call source, it's going to look in my working directory for files that I'm going to type out. And so for source to look for a folder, I have to make sure, or for a file, I have to make sure that file is within quotes. It's basically going to be read as a string. And so I go ahead and put in my quotes, and then I can just tab over, because it's the only directory it's the only file in this directory, so it's the only thing that will autofill, right? So I just put in source parentheses tab over, and R found the file that I'm looking for, right? So if I don't have parentheses and I try to tab over or anything like that, it's going to ask me what file do you want, right? But you don't have to provide the file, you just have to provide the file name. That's important, is to provide the file name within quotes. And so whenever I do that, that will go ahead and run, and now I have all of my code that I hadn't run previously. So like vectest2, vectest3, and saving A, I did that by running all the commands in the script as is. But I think if I just click the run button, it should do the same thing. We're going to find out. I don't know. It just did a little bit of it. So it just ran where my cursor was at. I think it just ran where my cursor was at. I think. Yeah, did the same thing. So if I just put my cursor there and click run, it's just going to run that single line. Didn't know that. You'll learn by playing. So anyways, so if I went to run this whole script, then the only way that I know how to do that is to source it. And also, another important shortcut is the up arrow key. And this is, so both the tabs and the up arrow key are universal to pretty much any programming language. So the up arrow key is going to bring back old commands. So anything that I've typed that has been saved by R, I can bring it back to this terminal by clicking the up button until I get to the line that I want to rerun. So for example, I want to rerun this script, I can hit enter, and it's just going to do it. And so I can modify this as is, so we can change I don't know what that's going to do. What can we do with R that I haven't done yet that we need to kind of know about? I don't know. So I'm gonna get to other data frames that are important, or other data structures that are reasonably important to R. But I'm gonna kind of wait till Friday to get to that. Today I just kind of wanted to focus on this scripting thing. So let's see what happens. I think I have an idea. So I have an idea. There is a function, and a nice thing about R is quickly simulating data. So for example, I can simulate data that would form a normal distribution. The data itself doesn't matter, but I can create data that would form a normal distribution with this command rnorm. And I've kind of forgotten how to use it, so I'm going to question mark it and bring up the help menu. I'm pretty sure I know what it does, but rnorm is to provide, what I'm going to do is provide a set of numbers that have a mean of a number and then a standard deviation of a different number. So for example, I can do rnorm, say I want 100 numbers. We're going to simulate a matrix of 100 numbers that form a mean around, let's do 10, with a standard deviation of 4. Why not? And so this is just going to reproduce that data. So whenever I hit enter, it's going to give me 100 numbers that's going to form a mean around 10 and a standard deviation of 4, plus or minus 10. Right? So it's just a nice way to simulate data. And so I'm going to go back to my script and just make that. I'm going to call it norm test. What I do, 100, 10, because I haven't saved it, so I'm just going to do it there and save it. So I'm just going to click save again. I'm controlling S to save it immediately. Go down to my terminal and rerun that source playing script. And now that line that I didn't have before should be present there now. Yes. So now I have a vector of 100 numbers with a mean of 10 and a standard deviation of 4. And again, the sweet thing about R is being able to quickly visualize a data distribution very, very easily. So I can use this command called hist, and it's going to create a histogram of that specific vector. So if I do hist of norm test, it's going to plot that data as a histogram. Right? That's convenient. Yeah. Okay. Neat. And so I think a couple of things. Plotting functions don't run very well. I don't think they run very well in scripts. I'm going to test that real quick, but I don't think they do. Yes, I want to remove that plot. So I'm going to put that command here, norm test. And again, I can autofill in my script as well. So I can do norm, right? And so my norm test already pops up of something I can fill this with. Again, you want to write, I mean, computer nerds are lazy. I think we get successful the lazier that we want to be, because like I don't want to type out norm test every time that I do so. I just want to type out no and tab and let it fill in for me, so I don't have to spend 30 seconds writing out norm test and then figuring out if I have misspelled it correctly or not. So tabs. Anyways, I'm gonna save that again. Control S to save, and run that script again. I don't think hist will pop up. Oh, it did. Look at that, it did. Look at that. So it does do that. Again, playing around. You'll learn stuff by playing around. running a command and seeing what happens, right? I mean, that's that part of science. Change something, see what happens. I recognize like that this distribution is a little bit different from the last one, right? So like the mean is still at 10, but we see kind of a left shift relative to what was previous before. It's because this R norm is that it's selecting random numbers, right? So it's kind of a random number generator, but we're just selecting random numbers that fit these two parameters, a mean and a standard deviation. So if I do norm test 2 and do the same thing, I bet I'll have slightly different distributions. So I'm going to leave that as is. Run that again. So I have it again, right? A completely different, a slightly different overall distribution. But part of that is this binning that's happening. So it's selecting, as part of this histogram, it's selecting bins, and it's calling all numbers between 0 and 5 of part of the same category. Also 5 to 10 is its own category, 10 to 15, etc. is its own category, and it's just summing up how many numbers were between these 2 points, 0 to 5, 5 to 10, etc. And I think every time that I run this, if I save it as is and then just kind of re-reference it, it's going to stay the same. But if I keep running this R norm command, it's going to keep slightly tweaking that distribution because I'm selecting random numbers. So for example, let's see if I do hist norm test 2. Again, slightly different. But $1 says I can make this more uniform. Let me bring up my hist help menu because I've kind of forgotten how to use it. Breaks, that's the important one. So this breaks option, hopefully let me make sure I'm not doing something stupid. Yes, breaks. Yes, breaks. So what breaks does is that it changes how many different categories you want present. So right in the default state where there's like no breaks, it's just gonna, I think it's just going to, by default it made 1, 2, 3, 4, 5, 6 categories. But I can manipulate that, I can change that. So I can set my breaks equal to say 20, and now I'm going to have 20 categorical, or 20 categories, and so like my numbers will be between, my categories will be like 0 to 2, or 2 to 4, or 0 to 1, 1 to 2, etc. And then just kind of recalculate the number of times a number fell within these two data points. But if we do that, it will probably normalize test and test 2 a little bit, and so they'll kind of ish, not really, show the same distribution, but that absolutely did not happen. And a couple other things about our norm is that the more you make it, or the more numbers you provide, the smoother this distribution will look. So if I do 1,000 numbers, I'm going to decrease the standard deviation a little bit. I'm just going to do a straight hist on that. Recognize I can kind of do commands within commands in R. And so we're going to get a very normal distribution. So the more data points we add, the more normal this is going to look. Neat. Again, we're just kind of playing around with what we can do, what we can visualize, and how we can use the software. This isn't necessarily practical yet. We're still just kind of playing around. Now, a huge advantage of RStudio over R is exporting these figures. So in R, it's really hard. I thought it was really hard to save a figure that I produced, either with plot or hist or something else. But RStudio, I can just go to export, and either save as an image or save as a PDF. So saving as an image is basically what's going to, that's what it is. But as a PDF, then I could probably edit that in like vector specific software, so like Inkscape or Adobe Illustrator or something like that. I can manipulate colors or manipulate text or things like that. But anyway, so I can just save that, and it's inherently, because I've set my working directory, it's inherently going to save this figure as a PNG. I mean, you can take your pick of what image you like the best, a JPEG, an MPB, whatever. I kind of go with default PNG. And you can change the size and width of that figure, and then just inherently save it. So now I can go to that test2 directory, and now I have both my script that I'm playing with and a picture of the histogram that I just took. So we can save stuff. We can save our input and save our output. And again, with default R, saving figures was always tricky and ugly and didn't work it was hard. But RStudio makes that a whole lot easier. Neat. And we've only just scratched the surface. Like, this is just kind of building on practical applications, is like saving all your commands into a script, making sure that's runnable, and you know, saving your output, figure output. Because, like, I don't know if I said this, like the primary reason I use R is to look at my data, right? So as a bioinformatician, it's not uncommon for my files to get, you know, thousands of lines long. So I certainly can't look at it. I have to summarize my data. And so as we move through R, that's how we're going to focus on using R. But recognize it can do so much more. It can do so much more than that, to any numbers, to it can do matrix algebra. We can do some stuff in phylogenetics. We can measure a lot of different things in biology with R. But I don't know how to do any of that. All I can do is plot stuff and make it look pretty, which I think has value, is to be able to visualize your data, so anybody that looks at it can instantly recognize what's happening. And I think the better you get at that, the clearer your presentation can be. So I think on average, on any given day, I'll probably only do this for like 40-45 minutes. So that being said, is there any questions about anything or something I need to repeat while we're here? Or is this all pretty straightforward? All right, if not, then I'm going to stop streaming, and we'll pick up this on Friday. But I know there's kind of a delay between what I say and when y'all hear it. I'm looking to start a new studio from blank. So if you want to start one from blank, you can go to File, New File, and start an R script. Oh boy. And so that will give you an option to start building a new script that's present. And you can do whatever you want with that. And then the nice thing is you can move between scripts. So R will kind of keep both scripts handy that you can edit. So I can go to my new unsaved script or the old script that I was playing with, and edit either one. So that's how you can start new files. Just go to File, New R script. Neat. All right. I think I'm gonna call it there. And again, if right, the nice thing about saving this in a public forum or a public place is you can revisit it whenever you want. If you forgot something or need to look at something again. Anyways, I'm gonna call it there, and I'll see you all again on Friday.